So today I'm going to talk about how to use Analytics Cloud to visualize Raspberry Pi sensor data along with the product data from Salesforce. My name is Jnana. I am a Salesforce architect at the Global Fund in Geneva, Switzerland. I'm also the founder and leader of the local developer user group. So let's get started. Please make your purchasing decisions based on what is available today and not from what I would say or what you would see in this presentation. So let's get a show of hands. How many people have heard about Raspberry Pi? Wow, that's quite a lot. How many people have played with one? Good. So this talk is going to be about using Raspberry Pi along with a sensor attachment to the Raspberry Pi called Sensehat. And we will look at how to bring the data into Wave Analytics, as well as bring product data from Salesforce and be able to see any patterns in Wave Analytics. And then finally, we conclude this session with additional resources to go further into the topic. So to get us started, what I have is a fictional scenario. Please don't go on the Google and search for universal healthcare. It doesn't exist. Or if it exists, it's doing something else. So the whole idea here is to establish a fictional scenario. The universal healthcare is a medical services company which provides procurement services to public organizations like the governments, the non-profit organizations, the private companies. They're basically based globally, and they have a B2B model. Basically, you're trying to give procurement services of important drugs. So one of the life-saving drugs, as you all know, it's the antiretroviral drugs that typically are used for HIV/AIDS treatment. Now, the way they work is that they stock all of the medicines in a network of inventory buildings, and this could be really at remote places. So it's difficult for having resources like air conditioning and many other controlled environments. So the products, as you can imagine, are very expensive and are prone to weather fluctuations. Now, recently, the company has received a lot of complaints that the products are not working as expected. Now, the idea then is to go ahead and investigate this further. So again, our fictional CEO is asking, what's happening? What is the actual financial impact to the inventory, and how do we make sure that this is not happening? We'll try to answer some of the questions at the end. So before I go into the details, there is something I want to make it a bit easier for us to set up to the stage. So how many people have defined actually what a thing in the Internet of Things is? So how many people have really understood what a thing in the Internet of Things is? Yeah. So it's basically, I'm trying to summarize what it is. It's basically three sets of components. One is about sensors and effectuators. Examples could be the temperature sensor, the humidity sensor, or the pressure sensor. And you can have effectuators which perform physical action, like motors and relays and speakers. Now, the other two important components of a thing is processing and storage, which typically is given by CPUs and microprocessors, microcontrollers, you name it. And then the radio communication through the antennas and standard protocols like Wi-Fi and Bluetooth and Zigbee as well. So in my case study, I'm going to use a Raspberry Pi. You all have seen it, but I don't know if you have seen the attachment on Raspberry Pi that provides you with all of the sensing capabilities. So I have it here. So Raspberry Pi, as most of you know, it has a CPU, 64-bit capability, and this is a Model 3. It has 1 gig of memory. It can be powered, as you can see, with a micro USB. It's quite easy to play with and prototype with. And what is interesting is this 40-pin GPIO connection that is expanding the capabilities. So this particular Sensehat goes on top of the GPIO pin, and it gives you all the capabilities, especially, as you can see, the temperature, humidity, pressure, and you also have a joystick that you can program as an input, as well as the 8x8 LED matrix to show the information on the screen. So in my study, I'm going to use just the temperature data to find out those questions, answers to those questions that our CEO wants to have. Now, the way you work through this attachment is through a Python library available, again, on a Raspberry Pi Foundation site. You do a pip install Sensehat, you get it. You basically instantiate it, and you call the get temperature method, and you have the data. And then finally, you can print it, you can show it in the LED matrix. So what I wanted to do is give you a quick demo. As you can see, the demo guards can be not very friendly. So what I'm going to do is I'm going to emulate, I'm going to simulate. So thanks to Trinket, it's an online-based, browser-based editing and learning platform. We have a, you don't see it. 1 minute. Got it. Okay. So what you see on your left side is your emulated version of Raspberry Pi with a Sensehat connected, and what you see on the right side is the code that we just saw. I'm going to just run this. Before I run, how does this emulator work? Right here, you see that there is a temperature value that is fixed. You have the pressure value as well as the humidity value. So it's kind of a simulation. It's a fixed temperature reading. So when you click run, obviously the code on your right side is running, and you see the value on the left. So imagine if the condition changes and the sensor picks up that. So I changed to 57, and we see that it is printing out the 56.7 as a reading. Okay, so that you get the idea. I have taken a reading, and then I have converted that into a CSV document. I have separately. We will see how to load that information into Wave Analytics. So let's go back to our presentation. So that is a logical step, the first part of how do we collect that information. Now we have the information, how do you load that into Wave Analytics? Now again, show of hands, how many people have used Wave Analytics? Okay, so I will take a bit moment to explain what Wave Analytics is. So Wave Analytics is basically the BI platform that Salesforce has acquired and integrated into their system. If you see the rainbow cloud of Salesforce, it is the green color of the Salesforce rainbow cloud. Wave Analytics has 4 basic building blocks. From the right to the left, you see that there is a data set. It's just a collection of related data. You have lenses, which is a view of the data. Behind the scene, it is a query, basically, that gets your data in a viewable fashion. And then you have dashboards, where you can embed those lenses into dashboards to have a meaningful management information. And then you have apps, which are basically a collection of dashboards, lenses, and data sets. And obviously, you can collaborate over it by just sharing on the platform, for example, Chatter. There is a nice module on Trailhead that I would encourage you to have a look at it. Up there in mini hacks or camp quick start, you can get to understand that. In our example, we're going to see how we can get the product and inventory data from Salesforce and the sensor data from the Raspberry Pi. Okay. I will now quickly show you the interface of the Wave Analytics. So in my org, obviously, as you can see, this is the Lightning experience. And I have collected a set of products and inventories. These are typically found in the marketplace. You can find them off the Google site, or there's a nice NIH-maintained AIDS info page where you can gather all this information. So what you have here is a set of products and their doses. The supplementary type, is it a tablet, capsule, and what is the unit price and the total price. So we have a collection of these. Okay. Now, if you want to see the Wave Analytics platform, in the earlier slide we saw the data sets, the lenses, the dashboards, and the apps. So you have that navigation here, and you also have a navigation for data monitor. Behind the scenes, it is an engine basically. So this engine needs to run to get the data from the sources. So you can go in there to see how your jobs are running. So obviously, some of them have run, some of them have failed. So that gives you a view of when the information is pulled in. Now let's go back to the slides. So we see that there are two ways to get information in. And in Salesforce way, which is the API first way, we have two APIs, right? So for products and inventories from Salesforce data, you have something called the data flow JSON, which is a definition of set of instructions to how to get the how to extract the information from Salesforce, transform and load it into Wave Analytics for you to further query. So how does this look like? So you have products and inventory data. You can extract using digest. You can transform using augment. And you can register using register. So finally, when you have this execution in Wave Analytics, you would have a data set named products_inventories. So I'm going to give a quick demo of how this could be done. So let me quickly jump over to Chrome. So for this, I'm going to use a tool that you can find on force.com, GitHub repository. It's called the Salesforce Analytics Cloud Dataset Utils. And in here, I see a definition that's empty. It is a data flow JSON that I can insert here. And I've prepared a JSON definition. I'm going to copy and paste it. And I'm going to save. What it's doing is that it is using the API and saving it back into Wave Analytics. Now, we have to go back to our screen and go into the data monitor and actually launch the job. Because by default, it doesn't launch automatically because it's not scheduled. I have not scheduled it. So on demand, I can do a start. And it is going to go read that information and go into Salesforce and grab the data. So as you can see, it is displaying that there is something happening. So if you would go into data set, if it is successful, you would see a data set created. It may take some time, depending on the requests that we have in the Trailhead zones. So voila, it's here. And so what happens when you click up the data set? You go into the query or visualization part of it. Now you can do many different things. You can view it differently. You can group it. Yeah. Let's say I want to group by products, and I see a particular product which has seven units in it. Without you get the idea now. You can do many several drill downs or grouping or clipping. You see a clip icon. You clip, and then you can decide what you want to do. So I'm a bleeding edge person, so I'm going to try it. So there is a dashboard builder. You can basically you can drag and drop, and there you have it. So this is kind of the whole idea of querying. So behind the scenes, what actually happened. So that's the old way of doing it. This is a new way. So what has happened in the lens is basically a representation of the query. And the query, as you can see, is called the Salesforce Analytics Query Language. It's based out of, it's based very similarly to the Apache Pig query language, which is within the Adobe and Apache Hadoop ecosystem, if you can imagine. So it's basically a big data way of doing things. Okay. Now, without going too much into the detail, I'm going to go back to my slides, and I'm going to talk a little bit about what it's good for the API. It's friendly for the developers, but what about the end users? How can they create? So the way you do it is using the native dataset builder, which I will show you in a second. As you can see, you have Salesforce as your data source. If you click that Salesforce, you go into an interface where you can drag and drop. You can search for your object in Salesforce, and you can select and build the query up. And then finally, when you save, it creates the data flow JSON, which we covered earlier. And the CSV data source, you need to be able to import CSV, and this CSV data source is helping you to generate what is called the metadata API. There are other third-party tools, as you can see, Informatica, Boomi, or Jitterbit. You can use whatever you have access to. So that should be good enough to bring the data into the system. Now, going back to the second way of getting the data in, which is the external data source, it is something like a mechanism that exists. There are a combination of 3 steps that you have to do, because CSV by nature, it doesn't have a metadata. You don't know which column is what type. So what you need to do is you need to define your metadata JSON, and so you first insert the metadata into an object, as you can see inside external data, and then you have to bring the CSV file itself as a base64 encoded string. All of these details are covered in Trailhead module, Wave Trailhead set of modules, and I have pointers at the end, so you don't have to really go into the details of things. So after the sensor data is inserted, you would then go back to the metadata record and say update with action is equal to process. So this tells the system to go and load the information into Wave Analytics. So if all goes well, you would have a data set in Wave Analytics. So I have shown you already how to import data using the Analytics Cloud toolset, which is the data flow JSON. And we will now see how to import the CSV data from the Raspberry Pi into Wave Analytics. So I'm going to go create. I'm going to create a data set. This is the native dataset builder interface I was showing you. I'm selecting CSV, and I have to choose. Oh, sorry, you're not seeing that. Are you seeing it? No. So okay. So I was creating a data set, I was choosing the CSV as a source, and I was choosing my file. And immediately, as you see, the system actually introspected the data and it created the metadata JSON. If you preview this, you can see that it has sensed the information in the file and it has proposed what would be the data format. So, for example, this would be of it's a measure. It can be, if it's a number, it is typically a measure, and if it's a string, it is typically a dimension, and if it's date, it's date. So it senses the format correctly. And if you want to overwrite this, you have an opportunity to overwrite this. Okay, so that's a UI way of importing data. Now, there are some limitations of the UI. It allows only 500 megs of information. And if you want to really load lots and lots of CSV data, you need to use the API, the external data API, which provides you nearly 40 to 50 gigs, I think. So that's quite a lot of power in the API. So I'm going back to the slide to move on to the third part, which is basically now how do you visualize the information to be able to go back to the CEO and answer the questions that he was asking for. Okay, so let's continue our navigation. I have prepared already some dashboards with the lenses, so we can start looking at the product data, for example. Okay, so let's look at the product information. So what you see is 15 ARV drugs in that particular inventory building. And you have 44 inventory items, which is composed of 26 different doses, which is like 100 mg per ml, or is it if it's a tablet, how many mg, all that data. And you have about 6,000 units, and with a total value of 6.6 million. Okay, and interestingly, what you see also is the recommended storage temperature. Storage. So what you see is a minimum of 2 up to maximum of 30. And I have also categorized what these mean. For example, refrigerating. So it looks like ritonavir requires a refrigerating condition. And in this building, we don't have a refrigerating. So it already tells me that it's something to worry about. So 698K could be impacted. Okay, so the additional visualization basically provides you a view of the information. In here, you see all the products in the inventory and their number of units. And on the right side, you see a funnel which is telling you what is the different types of supplement types of this. Is it a tablets, capsule, liquid, dispensable tablet? So it looks like tablets are very common in this particular inventory item. And then it goes on further to group the products by supplement types. And you can, Wave Analytics provide tools to elaborate and go into different directions based on what you're actually looking for. So for me, it looks very particular that maximum temperature of 30. Now I want to go back to my sensor data and to see if it is obeying this 30-degree maximum temperature in the storage. So what I've done is I've connected this in a room, simulating the inventory, and I've started to read the information out for a period of 2 months, as you can see, which is covering a period of 7 weeks. 1,000, it's per hour data, so you have 1,000 readings, and you see the minimum and the maximum. So 2733, which means already I can say that the total value of the 6.6 million is in danger. Right? Now, I've also further grouped by week, and you can see here that it starts to touch 31. Right? Maximum temperature is 31. So you have a fluctuated temperature reading, and it starts from here. So week 26, 27, 28, we have the temperature that's going beyond 30. And then it goes down again. So at least for the peak of June to July, you have to have a way to manage this condition. That's what it means finally. So this already provides you that information. One thing you can notice that the inventory data and the sensor data are not related per se, because it applies to all of the products. And so you need to really have a side-by-side view of finding this information out of just looking at the data. So let me conclude there, because there's a lot of ways to go further into the analysis. Let's go back to the slides. And so what can I conclude from this? It is the ARV drugs are obviously not stored as per the requirement. This financial value of 6.6 million of my inventory is at risk, at least for that 3 weeks period. And so the only way to go further and make sure that the conditions are maintained is by employing something like IoT cloud, which is able to do a real-time monitoring. And you can also further look at the cases that the customers are raising to see if number of cases go up during that period, right? So you can clearly see that augmented information that provides you an insight. And you also have something like the weather underground, which can give you the data, outside temperature data, so you can compare what's outside and what's inside, and to see if outside temperature goes high, does it affect my inside temperature? So there are different ways to take this prototype further. And you can also publish this as a web app within the organization, so different sections or departments of the organization can look at it and then act on it. So in summary, what we have covered, we covered we defined what a thing in the Internet of Things is. All my colleagues at IT IoT cabin are expanding and exploring all of that direction. We also saw how a Raspberry Pi and a Sensehat can help us prototype before going into IoT cloud. And we also saw the basic building blocks of analytics cloud and how that information can be brought in and how we can analyze and drill down. And we also saw, we observed the patterns in the data, and we concluded that the Raspberry Pi prototype needs to be expanded further and to be able to better manage and anticipate what's going to come in the summer months. So with that, I invite you to go into Trailhead. It's one of the resources that we have, not only for Salesforce technologies, but also soft skills and other aspects that we all touch every day. So there's a few collections of Wave modules. That's quite interesting. And there's additional information that I could not fit into the slides. So what I've done is given you a URL that you can go and collect that information. And I have 1 minute and 5 seconds for any questions you may have. Thank you. Let me ask a question. How many people have actually used Raspberry Pi in this fashion? You? Okay, good. Not with Salesforce. Oh, okay. We can talk. I can tell you a little bit. So, how many of you are very excited with the technology that you see up there, Einstein? You think it's a good thing? Yeah. So all what we have touched is aspects of IoT, aspects of Einstein, artificial intelligence, learning, and data. So at the end, if your data is good, you can infer quite a bit of things. Thank you.